Yes. Hello everyone, this is D. Chinnagokari. Welcome to our chemistry channel, that is Chemistry Masters Academy. In this video lecture, I am going to explain about the factors affecting on the rate of reaction. In previous lecture, I have explained some of the factors like concentration of reactants, nature of reactants, and also effect of temperature. One of the important effect, and I have given the derivation also at different temperatures by using Arrhenius equation. Next, in this video lecture, I am going to explain about the one more important factor, that is effect of catalyst. So here, what is a catalyst? Catalyst is a nothing but it is a chemical substance which alter the rate of reaction. So what is the meaning of altering the rate of reaction? It can increase the rate of reaction, which means it can speed up the rate of reaction, or it can slow up the rate of reaction. Means it may increases the rate of reaction, it may decreases the rate of reaction. So based on that, we are having two type of catalysts. One is positive catalyst. What is a positive catalyst? Positive catalyst increases the rate of reaction. It means it can, within the short time only it can give more amount of product, that is increase in the rate of reaction. Next, negative catalyst decreases the rate of reaction, which slow up the conversion of reactant into product. So how a catalyst alter the rate of reaction? Means a catalyst can alter the rate of reaction by changing the path or by changing the threshold energy and activation energy. So here we already know from the this collision theory and transition state theory. So if any reactant molecule wanted to convert a product, it should cross a minimum amount of energy. So this minimum amount of energy, it is called threshold energy. So this minimum amount of energy, it is called what? Threshold energy, and the extra energy required by the molecule, it is called activation energy. So here we are having three curves. So one is without catalyst. This middle curve is without catalyst. So in the absence of catalyst, this much of activation threshold energy required, and this much of activation energy is required. So that when you provide this much of energy only, the reactant molecule participate involve in the reaction and it can give the product. And when you observe these dotted lines, so it is in presence of positive catalyst. So when you are using a positive catalyst, what is happening here? Threshold energy is decreasing, and even activation energy is also decreasing. This is the activation energy in the without catalyst, and this is the activation energy in presence of positive catalyst. Means your activation energy is decreased, so that more number of reactant molecules convert into product within a short time only. And next, here, see, observe this. This is the, this curve represents negative catalyst in presence of negative catalyst. So here negative catalyst, what negative catalyst does? So decreases the rate of reaction. So how it decreases the rate of reaction? Means by increasing the threshold energy and also by increasing the activation energy. So here more amount of activation energy is there, so that less number of reactant molecules convert into product, so that it take more time duration, right? So this is about catalyst. So what are the characteristics of catalyst? Means so when you come to the characteristics of catalyst, a catalyst alter the rate of reaction. Means it can speed up the reaction or it can slow up the reaction. Rate constant also it can alter, means it can increase the rate constant or it can decrease the rate constant. Activation energy also, means it can increase the activation energy or it can decrease the activation energy. Path of the reaction, it can change the path of reaction. But a catalyst cannot alter the energy of the reactant. See here, in presence of positive catalyst, without catalyst, in the presence of negative catalyst also, energy or enthalpy of the reactant is same and enthalpy of the product is also same. So that delta H also will get same. Enthalpy of the reaction means delta H. Enthalpy of the reaction is also same. Free energy is also same and entropy is also same. Means catalyst can never alter the energy of the reactant and product, enthalpy of the reaction, and also free energy, entropy of the reaction, and also Kc, equilibrium constant. It cannot alter the Kc, equilibrium constant, extent of reaction, but it can make the reaction to achieve equilibrium quickly. Means equilibrium can achieve quickly in the presence of positive catalyst, whereas in the presence of negative catalyst equilibrium achieves slowly. So this is about catalyst. Now let us see the Arrhenius equation. In presence of catalyst, means whenever we see only catalyst, means we should consider only positive catalyst. Until unless they are mentioning negative catalyst, we should consider catalyst means positive catalyst only. So now let us see the Arrhenius equation with catalyst, without catalyst. Okay. So now let us see Arrhenius equation. We already know Arrhenius equation. K is equal to A into e to the power of minus EA by RT. Okay, so now we are taking this Arrhenius equation at different activation energies. Means different, when you get the different activation energies, when you are having catalyst and without catalyst. So that first let us consider this Arrhenius equation. Let us write ln K is equal to ln A minus EA by RT. So now let us consider in absence of catalyst. In absence of catalyst. So in absence of catalyst, ln K is equal to ln A minus EA 1 by RT. Same temperature only we are doing. So let us consider this as the equation 1. And in presence of positive catalyst, in presence of positive, in presence of positive catalyst, in presence of positive catalyst, okay, in presence of positive catalyst, so ln K. So now let us okay, ln K1, this is ln K2, that is equal to ln A. So ln A is the Arrhenius factor or pre-exponential factor. It is never going to change. That's why we are not labeling it as a 1 and 2. So ln A, that is minus EA2 by RT. Okay. So now let us consider. So we already know in presence of positive catalyst, activation energy 2 is less than activation energy 1. Or if you consider this as the, okay, E activation energy 2 is less than activation energy 1. Now let us do equation 2 minus 1 to get the relation between the rate constant in presence of catalyst, in absence of catalyst. So here what is the second equation here? That is ln K2 minus LHS ln K2 ln K1, that is equal to, so here ln A minus, so in second equation, that is EA2 by RT minus of ln A minus EA1 by RT. Okay. So now here ln K2 minus ln K1 will become ln K2 by K1. So according to the formula log or ln or log A minus log B, that is equal to log A by B. The same formula we are going to apply here. So now it will become ln K2 by K1, that is equal to, so here ln A minus EA2 by RT minus into minus, that is plus ln A, sorry, minus into plus minus ln A minus into minus plus EA1 by RT. So here plus ln A minus ln A will get cancelled out and it will become 0. So now ln K2 by K1 is equal to EA1 activation energy 1 by RT minus activation energy 2 by RT. Okay, so here EA by RT, so now it is looking like a similar fraction. So similar fractions we can write K2 by K1. So here denominators are same, that's why EA1 minus EA2 by RT. So this is the Arrhenius equation to find out the, which gives the relation between the K1 and K2 without catalyst. So here AA1 is without catalyst, EA2 is the in the presence of catalyst, R is the ideal gas constant, T is the temperature. So this equation we use to get the relation between the rate constant K1 and K2. So here K2 is in presence of positive catalyst, K1 is the in absence of catalyst. So this is about Arrhenius equation. Next, another factors which influence the rate of reaction, that is surface area. Surface area. So here what is surface area? Surface area means, so the area on the object what we are going to see with our naked eye, that is surface area. So this is the surface area initially. If I remove the this cap, again this is also will become the surface area. So here surface area is directly proportional to rate of reaction. So surface area increases, rate of reaction is also increases. So how we can get a clarity over this point means, children, so you just assume that burning of a log of wood, big log of wood, and burning of small chips of wooden pieces. So here when you compare log of wood and small wooden chips, small wooden chips catches fire very easily when you compare to the log of wood, because small chips of wood are having what, more surface area, so that they catches fire very easily. So this is about the factors which influence on the rate of reaction, and pH of the medium is also there. pH of medium, pH of medium is important when the reactions are taking place in the acidic or basic medium. There we can consider the importance of pH of medium. And one more thing, that is effect of light. Effect of light or radiation. So some reactions occur in the presence of sunlight only. For example, photosynthesis. Photosynthesis occur in the presence of sunlight only. So if there is no sunlight means there is no photosynthesis reaction also. And also the reaction between H2 and Cl2 is also occur in the presence of sunlight to produce HCl, hydrochloric acid. So these are the light sensitive. Some light sensitive reactions are occur in the presence of light only. In the optimal condition of light only they are going to occur. Okay, this is about factors influence on the rate of reaction. Okay, so thank you for watching. In the next video I am going to continue the this chemical kinetics chapter.